In this video, the resource will introduce you to the Powerlab software used to perform spirometry recordings, allowing the measurement of lung volumes. Secondly, it will also introduce you to lung volumes and lung capacities. First, select the Students folder, then select Chart. Finally, select the Lung Mechanics template. It is likely when turning up to a practical session that the Powerlab software will have already been preloaded for you. Once the software has loaded, in the top right corner, maximize the window and check that the sampling rate is set to 200 seconds, and the scale amplitude to 100 millivolts. This will be appropriate for measuring vital capacity, forced vital capacity, and forced expiratory volume. When you want to start a recording, simply press the Start button in the bottom right corner. This will then change to a Stop button. As you can see, this will start the recording at the sampling rate you have just set. The vertical scale measures the volume of air. This is the volume of air breathed in and out determined by the vertical movements of the trace, represented by the blue line. Breathing rate being how many breaths there are per minute. The horizontal scale measures the speed at which the trace records. The speed of the tracer can be set so you can determine the relationship between speed and time. To look through your recorded data set, use the scroll bar at the bottom of the chart. When a blue vertical line is present, this indicates that the trace has been stopped. You can pause your recording at any time to reset the chart. If there is unwanted data, simply click and highlight the data you do not require. Once highlighted, press Delete to remove it permanently. The spirometer connected to this software is a medical instrument used to measure lung volumes by determining an individual's rate of oxygen consumption. Hypoxia is a deficiency of oxygen in the tissue or an inability to use oxygen. It is not a respiratory disease in itself, but a consequence of respiratory disease. Therefore, it is important to measure pulmonary ventilation in order to monitor and assess the severity of a respiratory disease. Measurements made using the spirometer capture expired breath and record variables such as the rate and depth of breathing, speed of expiration, and rate of oxygen consumption. Here you should see what a spirometry trace should look like with normal inspiration and expiration occurring. The spike in the middle of the trace being a forced inspiration and expiration performed to help determine abnormalities in lung volumes. Lung volumes, also known as respiratory volumes, are used to assess an individual's lung function. They can be broken down into tidal volume. This is the volume of air exchanged for each breath at rest during normal inspiration and expiration. The tidal volume for most adults being about 0.5 cubic decimeters. Inspiratory reserve volume, or IRV, the maximal volume that can be forcibly inspired in addition to a tidal inspiration. Expiratory reserve volume, or ERV, the maximal volume that can be forcibly expired in addition to a tidal expiration. Tidal volume has a resting rate end inspiration and expiration. Anything beyond these points is forced. Residual volume, or RV, the volume of air remaining in the lungs at the end of a maximal expiration. Some air, about 1 cubic decimeter, always remains in the lungs as residual air and cannot be breathed out. Residual air prevents the walls of the bronchioles and alveoli from sticking together. This means there is a maximal inspiration and expiration that excludes the residual volume. Respiratory volumes can be combined to give respiratory capacities, providing information on an individual's respiratory status. Vital capacity, or VC, is the maximum volume of air we are able to inhale and exhale in a forced breath. Thus, this is the greatest volume that can be exhaled after maximal inspiration. This is a useful test of the ability to inflate and deflate the lungs. Inspiratory capacity, or IC, is the maximal volume of air that can be inhaled after normal expiration. Functional residual capacity, or FRC, is the volume of air remaining in the lungs after normal expiration. Total lung capacity, or TLC, this is the volume of air in the lungs at the end of a maximal inspiration. Once a trace recording has been made, you can look at specific sections in more detail by holding down the left-hand mouse button and drawing a box around part of the trace. Here I am highlighting the vital capacity to determine the forced expiratory volume. Click on the Windows menu on the toolbar at the top of the screen, select Zoom View from the drop-down menu, Your selected area of trace will now appear enlarged in a new window. Select and move the marker M, located in the left-hand corner of the screen, to the peak of the vital capacity recording. Using the mouse, move the cursor along the trace until you reach the base of the vital capacity. The size of the vital capacity will be calculated for you in litres directly above the expanded trace. The values you have just calculated will be in ATPS, that is litres at ambient temperature and pressure saturated with water vapour. However, we are interested in the volume of the gases that occupy the lungs, known as BTPS, that is litres at body temperature and pressure saturated with water vapour. Therefore, you will need to convert your measurements in litres at ATPS to litres at BTPS by multiplying the volume measured at ATPS by the appropriate factor for the temperature of the spirometer. Once you are finished calculating your lung forced expiratory volume, return the marker to the left-hand corner. Then click the Show Chart View window to return to your original trace recording. For more information, see the In-Depth section.